Are we on?
Yeah.
All right, I'm Phil McCaffrey. This is 8:30 prep, and I like to watch it on my phone. So as it started, functions. No, I picked the wrong one. Functions on the ACT. So there I am. Thanks so much to my producer Damien for the fabulous graphic of me as conjunction junction. What's your function? So here we go. Wait a second. What? Wait, where's the live chat? Nobody on the chat. All right. So today we're going to talk about strictly problems that I stole off the ACT. Tomorrow is going to be strictly problems that I stole off of the SAT. And I apologize for not posting a worksheet and doing a better job. One of the reasons I came over to the office to do it, and the SWAT team pulled up to take out a neighbor of mine in lovely, safe, and beautiful Ambridge, Pennsylvania. And so I was completely entertained all day by watching the SWAT team. And then, as some of my students would tell you, I was really happy to see the police dogs, and they let me see it, and I got to talk to the police. So I spent all the day talking to the police. Anyways, today we're going to just do problems of functions on the ACT. These are all problems that are on the ACT since 2016, since they changed. So they've kind of done a little bit better job with their functions to fight. Because they're fighting. They're fighting the SAT. So the ACT and the SAT are in a fight. One of the big things is if you're in public school in Pittsburgh or Pennsylvania, you have to take a test called the Keystone. And the SAT and the ACT are both fighting to replace the Keystone. It wouldn't hurt me, being a tutor, if either one of them won that fight and the state dropped the Keystone and I got to teach it. My fear is that they're going to pick up the SAT, and I really do like the ACT better. So if the ACT is watching and they're going to get mad at me because this is copyright infringement, this is flat out. I shouldn't say that. The bots will be watching. I flat out stole these off of tests that the ACT doesn't want to be put out in the public. Anyways. Math teachers always use the same problems. If a math teacher teaches for 20 years, he literally starts using the same problems because he knows the answers and he knows how to do it and he doesn't screw up. So the focus is on the student instead of the problems. My function problem is always the same. That is, a function is defined by f of x equals 2x plus 5. What is the function of 3? What do we do with the 3? We put it in place of the x. So this is 2 times 3 plus 5, which is 6 plus 5 equals 11. I've been teaching the same function problem for as long as I've been tutoring the SAT. Let's jump right into it and do an easy problem. I showed a couple of easy problems from the ACT earlier, and the one fun thing that I've discovered is this function of negative 3, in this case g of negative 3. I went through and I did read about 7 or 8 ACTs, and I think 4 of them had the function of negative 3. So this is something fun to teach. It's probably only fun for me. So let's put in negative 3 for both x's. And notice there's a negative and a negative. That's one of their favorite things to do. So we're going to have 2 times negative 3 squared. Put your negative signs in parentheses to square them. I've said this before. Negative 3 squared is equal to negative 9. Negative 3 quantity squared is equal to 9. This, people, is always screwed up in your calculator, and the government, how we got government on the brain. I can't believe I said that, Damien. The government, we're the only country that this isn't run by the government. This is the ACT. The American College Test, as it was first started. The government is definitely going to have negative 9 as one of the answers. Oh my God, I'm really messing up. Negative 3 times negative 3 plus 4. Write it all out. So negative 3 quantity squared is 9. 9 times 2 is 18. Notice how I do things in columns and write it out. Even on simple problems, I say do math like it's 7th grade, because this one counts just as much as question number 59. Negative 3 times negative 3 is plus 9. plus 4. Positive numbers, all of them, come over here and delete the negative numbers. 18 plus 9 is greater than 13. The answer has to be 31. It's got to be. So guess what? I estimated and I got the right answer because it's an easy problem. So one of the things that I do when I get a brand new ACT is I sit down, typically on a day where I can be by myself. I'll sit down at home, put the test out, and give myself a countdown timer of 25 minutes and try to do all 60 problems in 25 minutes and see how I do. I have only ever completely gotten them all right once, and I still have had to guess because that's really hard to do. All right, here's another easy one, and that is f of x is defined as the function of x is equal to negative 6x squared. What is the function of? You guessed it, negative 3. So we write negative 6 times negative 3 quantity squared. Great time to use your calculator. The TI-84. What did I do with my TI? Where did I put it?
It's right behind your computer.
It's right behind my computer. Here it is. This thing is great. The negative sign is right down there on the bottom. This is the one you're allowed to use on the ACT. Put in negative 6 times 9 and you're going to get negative 54. Your calculator is better at arithmetic and PEMDAS than you are. Practice using it. It goes in a certain order. The calculator is excellent for that. Thanks for the worksheets, Peyton. You are welcome. I've got one for the SAT to send you tomorrow, and it's going to be fantastic because I just got a whole bunch of new SATs that I downloaded off of Reddit. So they're called QASs. Remember, these are TIRs, and they are QASs, and you can go on Reddit, and there are subreddits, ACT, TIR, put them in and study for free. All right, I rewrote this one because it's a really bad photocopy, but guess what we have? The function of negative 3. This is literally off of a 2018 or 19. This is a year or two old. Really bad photocopy for being so young. So we have 3 times 3 squared, which we know is 9, plus 7 times negative 3 minus 8, and we get 3 times 9 is 27, minus 21 minus 8. And so 21 minus 8 is going to give me negative 29. 27 minus 29 is G, negative 2. Write it all out like that. Do not do this in your head. This right here is actually a great spot to use your calculator. Once you write it down, then put it in your calculator. One of the reasons students will grab their calculator and start doing it right away, and they've got what I call all the fat finger mistakes. It's only a number 10, but there are fat finger mistakes. I've done that on a couple of videos earlier. I can't remember which one was really fun. There's a geometry one, was where do all the mistakes come from? I don't really do that often, and I should. Like, how do they come up with 52? I should play with the numbers more and come up with the wrong answers, but it's something I really don't worry that much about. All right. Number 31. So now we're in the middle. The ACT has 60 problems. They go easy, medium, and hard. The first 20 are easy, the middle 20 are medium, and the last 20 are supposedly hard. Supposedly, if you're from Pittsburgh. And this one says, I really like this problem. This is a fun one. Given that the function of x is equal to 2 over the quantity x plus 1, what are the real values of t for which the function of t is equal to t? I get a lot of students stumped right here. They're like, what do we do with the t? It's just an x. So if you're one of those people that you're hung up on, I have to do algebra with an x, you can literally just say, this function is equal to x. I don't have to substitute t here, because it's going to give me the numbers. So I have algebra in the denominator, so I got to multiply both sides by x plus 1. I'll put a bracket in here and be myself really fancy. That means multiply it all the way through, and I get x times the quantity x plus 1 is equal to 2. X squared plus x, and I'm going to bring that 2 to the other side, negative 2 equals 0. And why I think this is fun is all of a sudden a function problem turns into quadratic factoring. So the ACT loves to sneak in quadratic factoring into all kinds of problems that don't look like quadratic factoring. And this factors into x plus 2 times x minus 1. And notice plus 2 and minus 1 are answers, but those are the factors. They are not the real values for which the function of t is equal to t. X is equal to 1 or negative 2. And let's see if there is a 1 and negative 2 only. Let me prove that to you. 1 is equal to 2 over 1 plus 1. 1 plus 1 is 2. 2 over 2 is 1. It's positive 1, not negative 1. Excellent problem. Good job, ACT. Hey, that'll be my podcast. Good job, ACT. You don't have the slurp cam?
I don't. Sorry.
All right. And number 10. Wait a second. How did a number 10 sneak in after a number 31? I wasn't paying attention. Oh, the reason I did this is because it's f of g of x. We have the doubled function. And what do? We do it one at a time. So there's one thing that bothers me more than anything else when I'm tutoring, and I have to keep a straight face and not yell at the student, is when a student says f times g times 4. It just grates on my nerves like nails on a chalkboard. It is the function of the function of 4. It's the function of f of the function of g of 4. So what do we do with the 4? We put it in for g of x, and we get 4 squared over 2, which we know is 16 over 2. Notice I'm doing math like I was in 8th grade, and every step counts, and that equals 8. What do we do with the 8? We put the 8 in for f. F of 8 is what the question is asking. So 3 times, instead of x, I'll put in 8 plus 7. 3 times 8 is 24, plus 7 ends in 1, 31. I love to stop here and notice last digit math. This is one. It's definitely going to be a lesson on 8:30 prep. Is this last digit math thing? They love to do it. I see how simple this is. 4 plus 7 is 11. I mean, 24 plus 7 equals 31 is pretty easy, but they do this on a lot of problems. Okay, here's another function of a function. They could also write fg of it, and there's also another symbol, f, this little tiny circle of g. They haven't used that in a while, so it looks like fog, but the circle is like a degree symbol down in the middle. Those both stand for the same thing. So the function of g of, you guessed it, here's where I got really happy, negative 3. All of these are since 2016, so they're all less than 4 years old, and it's a negative 3. So what do we have? We put the negative 3 into x squared. Oh my God. Everybody now has to know that negative 3 is 9. So this is 9 minus 4 equals 5. And what do we do with the 5? But put it in here, and we get 2 times 5 plus 1, which is one of my favorite problems, 11. Answer choice D. Cooking right along, baby. This is a beautiful problem. This is just a piece of beauty right here. Given that the function g is equal to x plus 1 over x squared, for which of the following expressions is equal to the function of x minus 1 for all x in the domain? Man, that is a mouthful. One of the things you can do here is plug in a number. If you really get stumped, this is a 46. This is a great time to use your calculator and plug in a number, okay? A great number to plug in here would be something like 6 or 7, something higher, because 1 and 2 might screw things up. Actually, 1 totally screws it up because it becomes undefined. Let's do it algebraically. Let's put in negative x minus 1 for x plus 1 over x minus 1 quantity squared. If you've seen my quadratic, definitely know your perfect squares. X minus 1 plus 1, the 1's cancel, and I get x over something. Let's stop right there, take a look at the answer choices, and notice 3 of them have x over something. That means J and K are wrong. I love to mark wrong answers very quickly and see what's going on. Take a look at the other answers. I have a quadratic foiling being squared. The answer has to be F because x minus 1 squared is x squared minus 2x plus 1. That is F. Learn how to estimate. Learn how to look at answers and see which ones could be right. Notice this bad boy right here, x squared minus 1. I think this is one of the biggest mistakes that I've seen students do, is that they take a quantity and instead of foiling it, they just square the two things in the quantity. And that is completely wrong too, because negative 1 squared would be positive 1. Beautiful problem. Just really good job, ACT. I'm going to just bust on the SAT tomorrow. Actually, the SAT makes beautiful function problems too. They make nice charts and graphs and tables. So we're going to have a really good looking one because I just got a beautiful new SAT that I haven't even looked at. So the graphs of the function y equals f of x, notice that's superfluous, is equal to x minus 3 squared plus 2, and y equals g of x is 1/2 x plus 1/2 are shown in the standard xy coordinate plane below. Which of the following is not true? I love a 54 that is just completely bothersome and long and tedious and then super easy. The absolute value of a parabola up in the air is equal to the absolute value of the parabola. You got to know that the absolute value of a parabola that is not moved below the x-axis is equal to it because 2 squared is equal to negative 2 squared. That is kind of the definition of an absolute value, and that is the negative is equal to the positive, so that is true. The absolute value of the function g of x is equal to g of x. Notice right here, there are negative values for the function g of x. I can get a negative value out of this if I put in anything like negative 4. 1/2 of negative 4 is negative 2 plus 1/2 is negative 1.5. That is not true. If it was, it would look like this. It would hit the x-axis and then all of the values of the function would be positive. That's a really good thing to know. Let me throw a page in there. In the xy plane, this is truly a good thing to know. And that is, if a line has an absolute value, it bounces or reflects. One of the nice things about it is this angle is equal to this angle. I should have used theta instead of x. All right, let's go back. The correct answer is G. Now notice what they've done. They've thrown in some really hard function problems that students will bog themselves down doing because they don't know that this one is not true. It's the right answer. I didn't even do these other two problems. Should we do one? Should we do one, Dame? How much time do we have left? What do you say, Peyton? Did you do this one?
We're at 25 minutes.
We're at 25 minutes. We'll say it's wrong. So 3 minus 3 plus 2. Let's do 3. 3 minus, because 3 minus 3 is 0, plus 2 gives me 2. And 1/2 of 3 is 3 halves plus 1/2 is 2. Yep, that's right. I'm going to bet that 3.5 works as well. And then g of 1 is put into f is 1/2 plus 1/2 is 1. And 1 minus 3 is 2 squared is 4 plus 2 is 6. That's right. All right, I'm not doing the 3.5. Screw that. All right. There we go. That was my little graph. All right, I love this question because it has absolutely nothing to do with functions. It has everything to do with understanding the minimum value of an absolute value. So the function of x is equal to blah, 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 absolute value minus q for each set of positive real numbers. What's the minimum value? I love this question. I love how the ACT makes absolute values so easy because the minimum an absolute value can be is 0. Absolute value measures the distance from 0, so the closest you can get, the minimum value, is to be 0. It can't be negative. So this whole thing, its minimum is 0, so the answer is negative q. Love this question. Yeah, like a chump, but I got it. You got like a champ. You're a champ, Peyton, not a chump. All right, what else do we have on here? Oh, I threw this one in because of translations yesterday. I forgot to include it. This is a brand new ACT problem. I want to say it's from 2019. The function f of x is graphed in the standard xy coordinate plane below. Here's the function f of x. It's some type of sine wave. The points on the graph of the function 3 plus the function x minus 1 can be obtained on the points. This is what I don't like about the ACT and the SAT, is that they often use the commutative and associative properties of algebra, and they write things that no algebra teacher would ever write. There is not an algebra teacher on this planet that would write this. They would write it as the function of x minus 1 plus 3, plus 13. That was beautiful, Philip. Plus 3. Well, we know what plus 3 means. We did this yesterday. It means go up 3. 3 units up. 3 units down? No. 1 unit up? No. 1 unit down? No. 1 unit down? No. Well, that was hard. It actually didn't ask me anything about this. Well, it did. It said 1 unit to the right because we know that, ready, parabola dance, up, down, left, right, thin, fat, flip. We know that up, down, left. I like up, down, left because up is add, down is subtract, left is add, right is subtract. Up, down, left, right. You should memorize that. And that, I think, is it. That is it. That is the ACT. Good job, ACT, even if you did stand for the American Wave the Flag Superman College Test. I'm Phil McCaffrey. I will see you tomorrow night at 8:30 for SAT functions.